Hi everyone, I'm Alan. I'm a senior machine learning engineer at DeepSense AI, and today I will talk about new cool things for building agents from OpenAI. So yeah, let's dive right into it. So last month, OpenAI released a few new tools for building agentic application. They announced it with this blog post, and today we will go through them and see how you can use them in your applications. So we have three of those tools, and first one being the new responses API. Then we will explore new built-in tools, and at the end we will talk about the Agents SDK, which provides a higher level of abstractions to use this responses API and built-in tools. So let's start with the responses API. So this is the newest API primitive from OpenAI, and it takes features both from the good old completions API and assistance API, and and slightly improves over them. And some of the key features in this new API are the same as in these previous ones, such as support for both text and images, structured output, and function calling. These features we already had in the previous APIs, but this responses API comes with like better history of the conversation management, which we will explore in the moment. And I think that like a big feature is new built-in tools that we will also discuss in a bit. Let's compare what we have now with this new responses API and what we have with the older but still valid and API that we still use, completions API. So as you can see, most of the features are available in both APIs. But if you want to use like text-to-speech or speech-to-text models, you should stick to completions API because the response APIs doesn't yet support the audio, but it is told by OpenAI that it's coming soon, so we can expect that in coming weeks or months we will have audio also in the responses API. And but we have new cool things in responses API, as I mentioned, which are built-in tools. And here we see that file search and computer use are examples of these tools. We'll explore these tools more later in the presentation. And also one key feature that is still missing from the responses API is a code interpreter. It's only available in the assistance API, but again, the same as with the audio, it should be available soon in the responses API. If you do not use like audio and code interpreter in your application, I would recommend to starting with the responses API. If your application is already using the completions API, you shouldn't like force yourself to move to response API too quickly, because all the new models will be available in both like completions and responses API. But also the migration from the completions to the newest responses API is not that hard. So I recommend it in like planning it for the near future. And and the next difference I wanted to show you is, I think it's pretty important, is between those APIs is the flow difference. So to achieve the same results, the flow with responses API is much cleaner, I would say. So here in this example, we want to use some image to search some information in the internet about something that is on the image. So with the old API, we would have to send an image to a model, ask it to propose a web searches that we want to perform. Then we will have to call a function for web search locally, get these results of the web searches, of this web search and send it back to the model, and then we will have this summary final response from the model. So you can see there is a lot of back and forth calling to the API, while with the new API, this all can be done within a single call to API. So we only send an image with the prompt to the model, and it analyzes the image, searches the web, and prepares the final output for us in one single API call, which, as you can see, simplifies a lot, and also it's faster from my experience to get the same answer with the responses API. And the pricing for models stays the same, so yeah, you shouldn't be worrying about that. And yeah, next let's look at the code difference between those two API. So as you can see, the new responses API is a little bit more like concise. And I think the two main difference here is that we used to have this messages in the completions API, but now we have an input parameter, and it can be either a string, which simplifies a lot because we don't have to provide this whole dict with role user. We can only provide a string, but we can also use as an input a list of messages, which is the same as it used to be. So it's like backward compatible in this sense. And also when we want to extract the final output, it used to be this well-known completions.choices.meshes.content, which is not very like clean and Pythonic, I would say. Now you can do it the same by simply responses.output text, which is, I think, much more convenient. And yeah, next let's look at the output difference from these two APIs. So on the left, this is the old API, and as you can see, there is this. The biggest difference is this how we send the message. So it used to be high-level key for the message, and inside we will have all of the content regarding it. And this was how it used to be in the completions API, and now in the responses API. The type is a separate field, and this allows us to have multiple different types. And we will see this in a moment that indeed we have not only message type, but also other types. And this new design of the API allows us for more, I would say, event-driven building more event-driven applications, because we do not have only this message type, but multiple types of the events, and we can like act accordingly in our application. So what are those different types? So we have the message type, which we saw before, but we also have 5 more, and 4 of them are tool calls, either built-in tool calls or the custom function tool call. And also the event can be can have reasoning type, which is basically the summary of chain of thought used by a reasoning model. And another cool feature from the responses API is how it allows us to handle the history of conversation. So as you can already see from these 2 code snippets, the responses API allows the same in much less line of codes. So how is it achieved? So with the completions API, you have to create like this array of the messages. You probably would store it in some database also, so it's not only stored in the memory. And then you append any new message from the API to the list and send it as an input to the API call. With the new responses API, the same can be achieved simply by passing to your next API call previous response ID. So the response object that we get from the API has its own unique ID, and by referencing to this ID, we can create a history. So as you can see, it's like you can use much less line of code and achieve the same, which again, I think it's a little bit more cleaner than it is with the Computations API. Okay, so let's now move to the built-in tools. There are three new built-in tools. The first one is a computer use. I think this one is the most interesting one. So basically, this tool allows the LLM to control or interact with your computer, either via web browser or some desktop application. But I think the web browser usage is the most well-known. You might have heard about the operator agent by OpenAI. So this operator agent actually uses this computer use built-in tool, which is really nice. The next tool is web search. And basically, it's kind of like a standard web search. This is something that we could already do with our local tools, but this differs a little bit because it uses fine-tuned GPT-4o, I think, to perform these web searches. And it's like I saw from the benchmarks that it gets this information better than non-fine-tuned models. So this is the advantage of using like the regular web search. And there is also file search that basically this tool allows you to do semantic or hybrid search through your uploaded documents. I would say it's kind of like a managed RAG from the OpenAI, and it nicely integrates with your models. So let's dive a little bit deeper into these tools. So first one is a web search, and as you can see, it's pretty easy to use it. So the difference between normal API call and call with this built-in tool is only this tools parameter, to which we pass a list of tools that we want to have available for a model. And after calling it, the model performs web search. Here in this example, we want to search for a positive news story from today. And we can see the responses on the right hand. And as you can see, there is a new event here, which is web search call. This is something that we talked a moment ago, that we can have now multiple type of events from the API. And thanks to that, we can react in our code. We can check for the type and do something about it in our agentic application. And let's look at the response from the model. So it's like a type of message, and under the text field, we have our model response. But there is another cool thing in this response, and it's annotations. And basically, this provides us with the sources of the web search. So model provided us with the response, but it used some web search to find additional information. So we can also see which exactly information was taken from another site, not generated by model, which is, I think, very, very useful feature. And the next tool is file search. So it's very similar to the web search when it comes to using it and responses. So as you can see, again, we need only to provide argument parameter tools. And the difference is that we have to also specify the vector store IDs. So this part of the code is only responsible for retrieving or calling the file search tool, but before we can use it, we have to first prepare the vector store ID, and we can do it either in OpenAI platform directly or via SDK. And to do it, we basically have to upload our documents, either PDFs or other files like Markdown files, and this vector store from OpenAI will handle the rest, such as chunking and embedding those documents. And then we can just only take this ID of the vector store and use it here. And looking at the response, we can see the next type of the event, which is file search call. Again, so we have already covered like 4 these events. And basically, the response is very similar to what we saw from the web search. So again, we have the text response from the model and annotation that includes the linking to the source documents. And at the end, we have the computer use tool, which is, I think, the most interesting one. So we saw the screenshot of it's either of some desktop application, but I think the most commonly used application is basically a web browser. And then based on the screenshot and prompt, model suggests us an action that we should take to achieve our goal. And you can see that in the output, we have those 2 remaining type of events, which is reasoning. So you can already see this computer use tool is using reasoning model under the hood. So we have reasoning event, and we also have a computer call event. So, and you can see there is no message text here. There is only an action, and you can see that model suggests us to do left click on some X and Y coordinates in our browser. And you may wonder, how do I integrate this computer use tool with my application code? So it's fairly easy because based on the screenshot, this model suggests you an action in form of this very simple JSON structure, and then your application basically have to convert this to actual action in the, for example, in the browser, and you can utilize, for example, Playwright framework to do it. And you do it over and over until the goal is achieved. So you send the screenshot, model suggests the action, you take the action, take a new screenshot, and so on until the goal is achieved. And this was the last from the built-in tools. And now let's move to the last topic of today's talk, which is the Agents SDK. And the Agent SDK is like a little bit higher level framework that allows you to interact with these components, these tools that we just talked about. And this OpenAI Agents SDK is built upon these core components. First one being agents, obviously, which is basically the LLM with some instruction, which is basically a system prompt, tools, guardrails, and handoffs. We'll discuss guardrails and handoffs in a second. So handoffs are basically a tool to transfer control over the agentic workflow execution from one agent to another agent. Guardrails are checks to validate the input output for some harmful or insecure input or output. And also this OpenAI Agent SDK comes with the built-in tracing, which is very helpful to view and debug your agents. So let's look at the code example of simple application built with the Agents SDK. So in this example, I've built an agent. We built an agent that takes some information about me, my location, and tells me what coffee shop I should go, taking into account my preferences at the weather. And there is a lot of going on here, I think. So let's quickly unwrap it. The agent definition is in the line 20. And you can see that it's very simple. You only provide the agent, the name of it, and tools that it can use. And you can see that we are mixing the web search tool with the fetch weather tool, The first one being this built-in tool from the OpenAI, and the fetch weather tool is a custom tool created by us, basically. And to use custom tools, we can use, as a custom tools, we can use any Python function. The only thing we basically have to do is decorate it with this function tool. And then having this agent, we are using a runner class from the Agents SDK, which is a manager for running those agents, because we can have multiple agents in one run. And as a default, it's async, but there is also a synchronous version of the runner if you need it. And you may wonder, what is the difference between like handoff and like traditional tool? Because we can use agent both in the handoffs and as a tool. So when we are using handoff, we are transferring control from one agent to different agent. So in this example on the left, we have a triage agent, which decides based on the user query if the given request should be performed either by billing agent or refund agent, and it only decides which one should take it from here and then transfers control to it. And when using agent as a tool, we have a different pattern in which we have like this one agent that acts kind of like a manager or supervisor of all of the other agents, and only calls agent as a tools, basically not transferring control to them, but asking them to perform certain tasks and getting the response from them, and like continuing with like, for example, talking with clients or other things that has to be done in given agentic workflow. And now I would like to show you a currently example, and this is very similar to the tools. The difference is that instead of passing instead of using the tools parameter in the agent class, we are using input guardrails parameter, to which we are passing a method, a function that we decorate instead of with the function tool. We decorate it with the input guardrail. And those guardrails works like this, that they're run in the parallel with the LLM, and they raise an exception if given condition is met, and the input guardrails raise the input guardrail triggered exception, and the output guardrail nearly the same exception, but with the output at the beginning. And they basically allow us to stop execution of the agentic workflow if something like malicious is like user tries to do some like malicious prompt, and we don't want to proceed with it. So it's very, very useful feature. And the last feature of the SDK is tracing. You don't have to basically add any code to take advantage of it. It works out of the box, and the tracing is available in OpenAI platform, in which you can browse your agent execution, and you can see there are traces and calls to APIs, calls of tools, and for each you have inputs and outputs, what type of model was used, the schema of the responses, which is very useful for like checking all of the steps of your agentic workflow, and basically debugging and seeing if everything's went okay with your agentic application. And yeah, that was basically everything I wanted to show you. So let's quickly sum it up. So we have this new responses API from the OpenAI that was built for building agentic applications. It combines the features from both completions and assistance API, and it has support for built-in tools. And those built-in tools are web search, file search, and computer use. And we can use Agents SDK to build application to use this higher level abstractions to use this responses API built-in tools with Python framework. And this Agents SDK provides with these cool abstractions such as agents, handlers and tools, guardrails, and tracing. And thanks a lot. I hope you enjoyed my talk. Bye.